Okay, so there's one missing piece of the triangle. I've got angle B is 55 degrees. And then let's see, with a little bit more work, I can find sides A and C. But here's where we're going to have to use our most recent knowledge, which is sine, cosine, and tangent. See, A and C are missing, and I can't use Pythagorean theorem there, and I can't use the fact that all the angles add up to 180. But what I can do is I can use the fact that I've got these trig ratios that work. So if I look at 35 degrees, I want to incorporate the 8, which is the adjacent side, and either the A or the C. So I'll go for C, which is hypotenuse, just because that's the one I wanted to pick. And if I'm going to utilize the adjacent and the hypotenuse sides, if we go back to, let's see, this chart, the adjacent and hypotenuse sides were incorporated by cosine. So let's see, we'll go back here, and let's take the cosine of 35 degrees is equal to, let's see, adjacent over hypotenuse. So now I have to solve for C. And if you remember, there's this cool little trick that says that C and cosine 35 can switch places. And that was probably back like an Algebra 1 trick you guys learned. And now in order to get C, all I have to do is take 8 divided by cosine 35. Well, cosine 35 isn't a cool table angle measure, so what I'm going to have to do is get the calculator out, and we'll just take 8 divided by the cosine of 35, and that'll give me 9.77. I'll be going out to 2 decimal places. So this tells me that C is approximately equal to 9.77. Okay. So now that I have C, I can also figure out A. And you know, there's a couple ways to do this. You could now use Pythagorean theorem if you wanted, but keep in mind that when you use Pythagorean theorem, that you're going to have to use this side C, which is rounded. And then you're going to round your answer to the Pythagorean theorem, which is like rounding on top of rounding. Now, your answer is not going to be drastically different, but it will be a little bit different than maybe someone who used the exact values that we have. For example, I did not round the value 8, and I didn't round 35 or 55. So why don't we go ahead and do a calculation, this time using maybe 55 degrees, just for fun. And let's use, if I use 55 degrees, let's use the opposite side and its adjacent side. So opposite and adjacent would be tangent. So I'll be looking at the tangent of 55 degrees, right? Since tangent is the only one that incorporates the opposite and adjacent sides, as we looked at here. Opposite and adjacent side, whoa, weird. Opposite and adjacent side was tangent. Well, if we go back down to our triangle, it means that we've got to use tangent to incorporate the opposite over adjacent sides, or 8 over A. And that means I can use that cool trick again to say that A is equal to 8 over tangent 55. And now just a real quick trip back to the calculator. We'll take 8 divided by trig function tangent 55, and we've got 5.6. So this means that the value for A is approximately equal to 5.6. Okay, so now I've got the entire triangle solved for, right? I've got all the angles, and now I've got approximations for all the sides, or at least rounded values. And I only went to 5. Yeah, that should be 5.6 because we're going to 2 decimal places. So we'll take a look at one more. This one's a little bit different because now I've got 2 sides and only 1 missing side. So I can probably use a different set of equations, but now I've got 2 missing angles. So I can't utilize that fact that the angles add up to 180 because I only have one of the angles, which is the 90-degree angle. I can start this out using Pythagorean theorem. So 4 squared plus 7 squared is equal to c squared. And if I do some quick work in the calculator, that'll get me c squared is equal to, well, 4 squared, I know that that's 16, and this is 49. So this is going to add up to 65. And you could have done that in the calculator as well. And then we're going to solve for c. We'll take the square root of both sides. And then going into the calculator, since I have not memorized the square root of 65 by heart, I know, and I call myself a math teacher, right? And that's 8.06. So that means that c is approximately equal to 8.06. And now I've got to get to work on figuring out these angles. Let's just go for angle, let's see, angle B. I don't know why, just because it's sitting there and it's staring at me. And that's the first one I saw. So I'm going to incorporate the 4 and the 7, which are the opposite and adjacent sides to B. And I really don't care if you call it opposite over adjacent or adjacent over opposite. But if you do go back to that chart, you remember that the one that incorporates opposite and adjacent is tangent, which we already have circled. So I'm going to have to take the tangent of B, and I'm going to have to say that's equal to the opposite side over the adjacent side. So that's the ratio. Well, it looks like B is my variable, but it's stuck inside of tangent. And if you remember how to solve for that back from last chapter, we have to solve for that by taking the tangent inverse of both sides. Tangent inverse is like the opposite of tangent. So that will be B, or I should say like the inverse of tangent. And that makes sense. Tangent inverse is the inverse of tangent. So B is equal to the tangent inverse of 4 over 7. Well, again, I don't know that value, but I know that my calculator does, so I'm going to go back and go into trig, and we'll take tangent inverse of 4 over 7, and it looks like it's 29.75 degrees. And remember to make sure that you are in degree mode in your calculator, so it's not spitting radians back at you. And we have 29.75 degrees. Okay. So since I know that B is approximately 29.75 degrees, then it means that I can go about calculating, I can calculate the value of A just by doing some simple subtraction. Okay, so we'll say that if I know that this angle is already 90, then A and B have to add up to 90, because 90 and 90 is 180. So 90 total between A and B, take away the value of B, 90 minus 29.75, gives me a measure for angle A of 60.25 degrees. Okay, so now we've got our second triangle figured out, where we had to use a little bit of tangent inverse, right? I'll kind of split this problem here. And definitely had to use a calculator for that work. And we also used a little bit of Pythagoras, so that was just fun, wasn't it, kids?